A very welcome to today's expert webinar on HTTP requests in ReactJS. I'm Ankita from SpringPeople. We are India's largest enterprise training provider. I will be your moderator for today's session. We are thrilled to have you with us for this exciting session. Today, we are going to explore how you can make HTTP requests effectively in ReactJS. But before we get started, let me introduce you to our esteemed speaker, Mrs. Pallavi Prasad. In today's session, we are honored to have Mrs. Pallavi Prasad, an accomplished corporate trainer dedicated to bridging the gap between technology and business. Pallavi brings a wealth of experience, having conducted 500 plus successful training sessions. She has earned acclaim as a trusted expert in her domain. Her ability to simplify technical concepts ensures you leave with practical takeaways. She is committed to helping professionals like you master skills that make a real impact in the workplace. Pallavi Prasad's unwavering commitment to delivering timely and impactful training consistently adds value to organizations, ensuring participants are adept at applying their knowledge in real-world scenarios. Join us for this insightful webinar to learn how to make efficient HTTP requests in ReactJS, integrate APIs into their React applications, improving the user experience and overall app functionality. Now, participants, if you have any questions, please do share them in the chat box. They will be answered at the end of the session. Without further ado, let's start today's session. Over to you, Mrs. Pallavi.
So, welcome everybody. Today's session or today's webinar is about HTTP requests in ReactJS. So, the agenda for the day today is this. We are going to have a quick look at how HTTP requests work and about use effect, async and await. Main part of this webinar is to look at errors that occur in HTTP when we send HTTP requests. And we'll also have a look at how to, have error-free requests when we send HTTP calls, API calls, basically. So one of the things about whenever we work with web applications, whenever we create a front end, one of the things about working with a web application is, or should I say an integral part of working with web applications is when we make these API calls to various servers. Now, when we are making these API calls, we usually send a request and expect a response back from the other side, basically the server on which my database may be hosted or whatever is serviced by this particular API call that I am making at present. Now, when we work with various different front ends, various kinds of web applications using multiple technologies, there are different ways in which these calls are written, but in essence, the way the calls are called, or should I say the way we make API calls, is in essence a pretty common way everywhere. You need a URL, basically, whenever you make a HTTP call. And if you're making a post request, you need a payload to go along with that URL that you're making use of. Now, this is basic of any API call that you make, whether you're using React as your front end or Angular or anything else for that matter. The API calls basically follow this particular pattern. Now, if you come to ReactJS, so when we work with ReactJS, basically, we have three ways normally in which an API call is made with ReactJS. One of them is XML HTTP request. And the second one is fetch API, and the third one that we usually use now is Axios. So there are three of them basically. So if you look at a quick touch upon this, basically, I'm not going to be working on this more than necessary. Here I've mentioned these two only on the slides, Axios and Fetch API, because they are more commonly used compared to XML HTTP request. But the reason for that is because the XML HTTP request happens to be a low-level API. It provides a very basic mechanism for making these requests, and the developer has to take care of handling the response, or parsing the response, handling the errors, whatever is the state of the response. All of that is falling on the developer. Now if you take the other two APIs that we have, the fetch API and the Axios, basically, so these are much more comprehensive in terms of being much more modern. Fetch API happens to be promise based for making any kind of HTTP requests, and it's pretty simple, it's flexible, it takes care of handling the responses from the server. So it basically makes the developer's life much more easier. And the same goes for Axios as well, in terms of it being a very popular JavaScript library, and it works great with React, basically. So, a fetch happens to be inbuilt, but along with the browser, basically. But Axios, you need to install Axios as an independent JavaScript library into your React web app that you're developing. One. Second thing is that when you work with Axios, Axios makes it easy to work with asynchronous requests, which is the ask of the day today. We don't want to wait for a response before we are going to be sending the next request. So that is basically an update on, or should I say an overview on how to work with these HTTP requests. Now, if I'm going to be working with HTTP requests, I have to be able to send the requests in multiple ways. One of the ways that you can send the request is by using the use effect hook that we have. Other than that, we also have two other ways in which you can send the information. It is by using async and await. So you can quickly have a look at how these work as well. So when you're working with, when you're working with Fetch API maybe, or Axios maybe, we do work with the use effect hook. If you are already familiar with React, you know what use effect basically does for us, and how it works basically. What it basically does, as you know, is that it provides us with, see, hooks, as you know, are used with functional components. They're not used with class components. So if I'm working with use effect, this renders immediately. So use effect, basically, this hook helps me to render my content immediately whenever an app mounts. So we always work with get requests essentially within the use effect. Along with this, we usually use use state, because this is used to manage the state of whatever is the response that we are going to be getting. So that is in effect what we do with those two. If you have a look at the a small screenshot that is there on the screen, you will notice that the API call that I'm using is actually a GET request. I'm using the fetch API here, and this is basically for working with the fake API server that I have, a fake JSON server called as JSON placeholder. This is just a test code that has been written, and we normally work with a fetch API in this particular way, where we use effect and get it to work with us. There have been a few minor mistakes on the slide and everything, but please ignore them. So the next is if you're going to be working with the same, see, fetch basically is synchronous in nature. So all I have to, every time I have to wait for a response before the next request can go. In case of me wanting to work with asynchronous requests, we use what we call as async and await. So you have a look at how async and await work. Fetch works in both ways. I mean, with the functional component and the class component. So what you are seeing here is an example of how to work with the async and await inside a, this is inside a class component basically. So I am using what is the the component did mount functionality that is there here to quickly work with or handle a simple asynchronous call here. So I want to be able to fetch the data and load it whenever the component mounts, basically. And it has to be an asynchronous call. So we are going to use async and await to do that. Now, as you know, any asynchronous call is by using this particular combination of async and await when we work with the fetch API. But what about if I don't want to work with the fetch API? The other more commonly used JavaScript library that we have is Axios. Another small clipping, or should I say another small look at how it works with the Axios. I'm not showing any class components here. These are all functional components that I'm showing you here. Simple reason being it's comfortable for me to, I'm more confident, or should I say I'm more I lean more towards functional components. So that's the reason why most of the examples that I have on the slides are all about functional components. So as you can see here, we are again using the same thing, the difference being that we are using Axios. So I'm using Axios.get here. By default, Axios works with asynchronous functional calls. So we don't need async and await normally when we work with asynchronous. I mean, Axios, it makes it more easy to work with asynchronous calls when you work with async and await when we're working with. I think I went backwards. I'm sorry. Yeah. So this is again, I think it's a repeat of that particular slide. I think I made a mistake here, but okay. Now that you have an idea of how Axios works, or you know how this works, let's have a look at one of the more important parts of this webinar, which is what are the kinds of errors that will turn up when you work with React, whether you're using Axios or a Fetch API. When you work with HTTP calls, basically, you are going to have to look at issues that occur with React. Now, React has multiple kinds of errors that turn up, basically. So let me just, yeah. So let me just take a look. Let's just quickly have a look at what are the different kinds of errors that we have. So when we work with React, we have syntactical errors, true. We also have errors which are component based as well. There are errors which occur during rendering. So these are all, basic errors that do occur when we work with React. One of the ways we handle these errors is by working with try and catch blocks maybe, or setting up what are known as error boundaries, or working with unit testing, etc. Now there are another set of errors that occur when we work with React, or should I say any web application, wherever there are API calls, and those are your basic HTTP errors. So these are response codes that you get when some part of your API is not working the way it is supposed to. So what is the major problem that occurs here? Now let's take a very small example. Let us say that I'm trying to move to I'm trying to run a GET request basically, and I get a 400 error or a 404 error or a 401 error, or one of those major error codes that we usually get in response. It could be a 500 error. I don't know, any of those errors that we have. So how are we going to handle these errors? I mean, they are all errors that have happened during rendering. They happen during API calls, basically, whenever my component is getting mounted. So how do we handle that? Now, whenever we are going to work with any kind of a web application, error handling has to play a major role. It has to play a major part of web applications to ensure that there is a very clean way in which your web application remains functional even after a particular issue occurs. Sometimes what we do is we create what we call as error pages, which pop up if we have the wrong route maybe or something like that. You get an error page. That is one way in which we do ensure that the user comes to know that there is a small mistake that is happening, or we tell them that there is a small break, please wait, we'll fix it. So there are multiple ways in which we inform the user that there is an error or an issue that has occurred. Now, but as developers, when we are going to write the code, how are we going to work with it? What is it that we are going to do? So let us take a small example here. Let us say in this particular example, I'm trying to retrieve some data from a particular example. And the data that is coming out is not working the way it is supposed to, or I'm not retrieving the correct kind of data. So because this is a problem with async and await, using async and await, it's asynchronous, we need to be able to figure out a way to work with it. One way to work with it is to handle it with a try and a catch, as you see here. So if there is an error that is coming up, which gets thrown, we capture the error through our simple console. This is one way. Second way that we can work with API errors is, whether you're using Fetch or Axios, is you can write your own custom error handlers. Now, when we are working with custom error handlers, we are going to have to write our own custom error cases. So here you create a simple, let us say for a 400, you write a function which will handle the request. Let us say handle bad request, then you have one for 403, which shows you what is the error that is occurring. Then if you have a 404, it's a not found error. So for each of these codes, we can write our own very specific error handlers. We'll come to that. I have I think something on this one that I can show you about that as well. Now, another thing about Fetch API is that it uses promises. So when it uses promises, it does, you need to have proper error handlers which allow you to handle the errors that could occur when you have promises. You also need to be able to provide it with a retrying logic when you're working with promises. So one way is when you use a .catch, fetch.then.catch. So any promise.catch, this is another way of handling whatever errors that you have in a very concise and clear, clean manner. One major thing that we need to keep in mind when we are working with error handling is that we want to ensure that there is no break of our code when we are actually deploying the code. So any error handling mechanisms that we write have to be tested and tried before our code goes into production. Once it goes into production, there is nothing we can do. So before it goes into production, we need to ensure that everything is working the way it is supposed to. And one of those is to ensure that we have appropriate error handlers. Now, one is fetch. Fetching, writing a try and a catch, or working with promises with fetch is pretty easy because fetch is very simple. It is an inbuilt API that is available with React when you have your React browser. But that's not the case with Axios. When we work with Axios, the way you handle errors in Axios is comparatively different. Now, what happens? So whenever we work with Axios, basically Axios, as I already told you, is a very popular and a very easy to use, JavaScript library that we have, that we can add through an npm into our React application. One of the most common errors that we have that occur in case of Axios is what we call as request failed with status code 400. Now, there are multiple reasons why this particular error could occur. And one of the main reasons is it could be that the URL that we have is not formed correctly. Again, could be because it's missing a particular syntax. Some syntactical issue could be, or if the request is unauthorized. When we are working with web applications, one of the main things that we concentrate on is authorization and authentication. So we do add authorization and authentication libraries to our application, ensuring that whoever is the person accessing a particular API is actually authorized to access that particular API. Now, in case that person does not have the necessary permissions, then obviously certain API calls cannot be made. That could be one of the reasons when you get this particular Axios error. So again, lack of permissions is one of the reasons. It could be that you're accessing a protected resource, or it could be because there was a server issue. The server may be down due to God knows any number of issues. It could be something as simple as a network failure as well. So whatever may be the issue for generating this particular error, how are we going to handle it? What is it that we are going to be doing? For us to be able to handle any errors in Axios, the first thing that we need is to understand how an Axios error object looks. So when you're working with error handling, you need to look at the Axios error object. So your Axios error object is basically made up of two parts. As you can see, you have the response and then you have the error. Those are the two parts to an Axios error object. Now, this error object has different parts to it, and those parts are you have a response, the message that the error comes with. There is a configuration, whatever configurations for that particular error, like where is the which is the API, which is the IP address that is responding back with an error, what is the payload that is being giving a problem, etc. All of that happens to be a part of the error object that we have, along with the response, what kind of request was sent, and which is the URL that was hit uh, through the request. All those informations are available to you when you work with an Axios object. Now, how do you handle? There is one other way in which you can work with error handling in Axios. Now, before I continue with or look at all of this, there are a couple of other things that I would like to touch upon when we work with Axios, and that is that whenever we work with any kind of error handling, whether it is with Axios or without Axios, we need to remember that this is mandatory in any kind of an application that we write. So a good application always means that you are going to be working with error handling as an integral part of your crucial part of your web application. Now, whether you're writing your code in JavaScript or you're writing your code in TypeScript where React is concerned, it is immaterial, because you have to make sure that there is proper error handling that is occurring. Now, when you're going to be working with interceptors, this is a long piece of code that I have up here. It spans multiple slides. So before I continue with that, I wanted to take you through that one small requirement. Now, what is this interceptor that we are talking about? What does it mean? let us just understand it in a very simple and easy manner. So an interceptor is basically a method that is triggered before or after a particular issue occurs, maybe, or a particular error occurs, anything. Now your interceptors are basically of two types. You have what are called as request interceptors, and you have another one called as a response interceptor. So what these interceptors do is that if you're going to work with a request interceptor, it allows you to write a piece of code and execute a piece of code before your request gets sent. So what you're going to be seeing here is a interceptor that has that is a response interceptor. Now, so let us assume that I'm sending a get request. So before the get request goes, I want certain steps to be followed. That means it has to cross check a few things. Those parts I will write in a request interceptor. Now, whatever response is coming in, now that response, when it comes in, I want to be able to check the content of the response. So then I write a response interceptor. Now interceptors can also be used to handle errors. So these error interceptors are used when you're going to be working with multiple kinds of errors in Axios. The easiest way is to work with this. So let us have a look at what this particular error interceptor is. As you can see, there happen to be four separate models that I have. Education, experience, project, and skill. And there is a base URL, as you can see on this particular slide. Now, what I have done is here I'm writing response interceptors. So we use access.interceptors.response.use. Here, what I'm doing is I'm checking to see what is the status codes. So in case whatever is the response that I'm getting out of my, let us say the get request that I have sent, whatever response I'm getting, I'm checking to see how the response is. Now, if the response has no issues, then fine. But if there is an error, now what I want is I want to check based on the response of the error. So the response of the error is basically based on the status code. So if the status code is 400, I want it to do something. If it is 401, I want it to do something, and so on and so forth. So I have written it for about 405. Now, in case there is no error, there is no issue, and the response is coming out safely, then I am going to handle the request or the response. Now here I have written a request, that is a simple one. So all I'm doing here is retrieving data and handling whatever issues are occurring from the get request or the put request, post, or whatever HTTP request that I'm working with. That is what I am working with. Now, whenever you're going to write a Axios interceptor, we have to use certain, there is a key that we use, and this is what we do. We say axios.interceptors.request.use for a request interceptor, and axios.interceptors.response.use for a response interceptor. Now here in this case, as I already told you, this is a response interceptor, which is going to double up as an error handler as well for me, because I want to be able to handle whatever are the different kinds of errors that could possibly get thrown. Now here I've written about 4 or 5. There could be other errors that you would be expecting. You can put them here as well. Now, once you have your errors, once you've, once you've handled your errors, then you can take your project one step further. But this is not the end of it. I mean, if you're going to write these interceptors, you have to remember to configure these interceptors and work with them. So when you're configuring the interceptors, you are going to be checking for setting up the headers for the interceptor. This is a partial one. I mean, it's not this one. So what we usually do when we are working with the interceptor is that we also look at how the configuration is written. So when we talk about a configuration, especially when we are working with a request, not for a response, what you see here is a response. So when you work with a request, we usually specify a configuration for our interceptor. The configuration specifies what are the headers that it should work with, what is the token that it has to take. Now, if the token is an authorized token, then obviously the API is going to be allowed. If it is not, then it is going to be rejected. So when it is rejected, I want to be able to handle the errors. See, because a rejection also happens to be a response that is coming back. So if I get a rejection as a response, I should be able to handle it. So I'm writing the various content in this particular way. And that is how you are going to work with it. Once you have your error handler written or your request and your response interceptors written, then all you have to do is integrate these interceptors into your code. So when you're integrating it into your code, all you're going to be ensuring is it becomes a part of wherever the API calls are. So that's all there is for you to remember about interceptors when we are working here. But do know that when we are working with Axios interceptors, there are a couple of things that you have to remember. These interceptors will intercept every request you make. It will update the request with whatever is the authorization header and the API keys that you have based on how you have set it up. It will also forward the requests based on, again, your configuration. So once a particular request is resolved, that means it is served properly, then it will take the response, handle it with the necessary checks or filters or whatever that you have set, and return the response to you. Once the request is completed successfully, you can handle that as well. You can write the interceptor for any kind of work that you would like to work with. So I'm assuming that that is clear to everybody. You can, one of the easiest ways to work with Axios error handling is by writing interceptors. Now that you have an idea about this, one of the few things that we have to keep in mind is what are all the best practices that we have when we work with error handling. Now, some of the best practices that we have to keep in mind are what I'm going to show you. Now, these best practices, I have mentioned only a few of them. There are a lot more that are there. You might find that there are ones that are based on the component. So if you're working with a class component, how do you work with it? If you're working with the functional component, what are the best practices for handling errors, etc., or for writing error-free requests? So for all of it, there are a lot more, but I'm going to be taking you through a few of them only. Now, one of the first best practices that we have is that you need to be able to write robust error handling code. So you need to provide fallbacks or retries wherever appropriate and wherever necessary. Remember that don't write a generic error handler for all the errors that you have. Each error type of error should have its own specific handler. So if you're working with networking errors, they should have their own specific handlers. So that's one of the reasons why we work with or why we write interceptors. I mean, if you have noticed in the code that we saw earlier, you would have noticed that we are writing a handler for each of the different status codes that we are getting or response codes that we are getting. So each of these error types that you're seeing here, client side errors or server side errors or whatever kind of errors, they all have a specific set of status codes. So, you can write your interceptor to handle those kinds of error code responses as well. But remember that you have to, which is one of the reasons why we say, please test your code before you send it up to protection. Second thing is that you need to implement what we call as input sanitization. You need to remove all kinds of anything that you feel would be malicious and extraneous. Sometimes you have these special characters that come in your code that are in your input based on, I don't know, could be a part of when somebody is typing something, maybe a particular keyboard, different kind of a keyboard that they might be using, could be anything. So what you want is to ensure that you allow for only certain types of data to be there in the input and not everything. So don't, you will have noticed probably is that in some websites, when you are going to be creating, let us say, a username, you can use a dot and an underscore. You can't use a hyphen or any of the other special characters maybe. So there are certain restrictions that are placed. One way of working with input sanitization is that you need to make sure that whatever requests that you send are safe and they are correctly formatted. Any input that you send should not create a security breach at all. So you need to ensure that whatever websites that you are developing, which expect or accept input from the user, have some kind of a sanitization policy associated with it, some kind of a logic that is available in sanitizing for input sanitization. And another thing that I already mentioned earlier was that a user should understand the error, whatever the error is occurring. It shouldn't be generic. It should be something like, oops, sorry, nothing like that. You should ensure that whatever is the actual error that is occurring in terms that the user can understand, that the error is shown up there to the user so that he or she knows whatever is the reason that they are facing that particular problem. Wherever possible, implement your retry logics based on the error code. Now, sometimes what happens is that, I don't know, maybe the server is down due to some reason. You may have something called as an internal server issue, 500 code. So you want to be able to hit the API or run the API once more and try to hit the same URL once more. You want to run the call again. You can allow it to run the call. Let us say you have a counter which allows it to hit that particular API link couple of times before an error is declared. Maybe you can try something like that. It's just an example. So appropriate retries, appropriate fallbacks, it's always good to have them based on the kind of error that you are facing. Doesn't have to be because it's a network error. It doesn't have to be a generic one for all network errors. It could be more specific to the kind of network error that you are getting. So make sure that whatever fallbacks and retries that you write are error specific. And finally, when you're working with any web application, any application period, it is always good that you have appropriate testing mechanisms in place. Please perform extensive unit testing, end-to-end testing, wherever appropriate, to make sure that every call is working. Make sure that you use appropriate tools to monitor all your various API endpoints so that you can identify and rectify whatever are the reasons that lead to these status code 400 or whatever other errors that could occur. Make sure that your request handling code behaves as it is supposed to and does not deviate from whatever path it is supposed to take. Please monitor the health and performance of your API endpoints and your APIs. Set up alerts whenever whenever an issue occurs for you in any particular way, so that you know where to go and fix that particular problem. And that is all there is for this particular webinar, people. Would like to send it across to my colleague Ankita. She will take over. Ankita, over to you.
Yes. Thank you so much, Pallavi, for such an engaging and insightful session. I'm sure everyone here has picked up strategies and techniques they can apply. Now, if you guys are interested in learning more about HTTP requests in React.js, do check out our discounted batches of virtual instructor late trainings on our website, springpeople.com. These VILT trainings are leveraged online from the comforts of your home and flexible as per your schedule and location. If you do not find any suitable batches, we'd be happy to discuss and schedule private batches for you. And if you don't have time to join live online, then do try out our affordable self-paced courses. And for more information, do write to us at training@springpeople.com or call on our number displayed on the current slide. Now, we are going to open the forum to answer questions if we have got during the session. So let's get our questions answered, if any. I guess there are no more questions. Anyways, thank you everyone. We appreciate you being here. We shall be sending out the webinar recording to all participants soon. I request you to kindly provide feedback before signing off, which will really help us improve the quality of future events. Thanks again for joining us today. Signing off on behalf of Team People. Hope to see you again for our next expert webinar. Take care. Bye.
Thank you, everybody.